Okay friends, in our class, let us know about the electrode potential, that is single electrode potential, right? So the electrode potential is nothing but the tendency of an electrode to lose the electrons or gain the electrons when the metal comes in contact with the electrolyte solution having its own ions. That means whenever a metal comes in contact with the solution having its own ions, either it will undergo oxidation, either it will undergo oxidation by losing the electrons, or it will undergo reduction by gaining the electrons. So this tendency of an electrode to undergo oxidation is called as oxidation potential, or the tendency of an electrode to undergo reduction is called as reduction potential, right? So for a given electrode, always the reduction potential value is reverse to that of oxidation potential. For example, for a given electrode, if the reduction potential value is equals to 1.5 volts, then its oxidation potential will be minus 1.5 volts. That means for a given electrode, the reduction potential value will be reversed to that of oxidation potential, right? So usually the single electrode potential value depends on three things. One is concentration of the solution, temperature, and as well as the nature of the metal. So here the single electrode potential value depends on these three things. So if at all the single electrode potential value is measured under standard conditions, then that is called as standard electrode potential, which is represented by E naught. So the standard conditions means if we take the concentration as 1 molar, temperature is maintained at 25 degrees Celsius, then the measured single electrode potential is called as standard electrode potential, which is represented by E naught. Right? So we must note here that the single electrode potential value for a given electrode cannot be determined experimentally. But the potential difference between the two electrodes can be determined in a electrochemical cell. That means we can determine the potential difference between the two electrodes, but we cannot determine the electrode potential singly. So for that, in order to measure the single electrode potentials of all the electrodes, what we do is usually we will connect it to a reference electrode and we make a cell. In order to determine the standard electrode potential, what we do is usually we will connect the electrode to the reference electrode, that is normal hydrogen electrode, whose standard electrode potential is arbitrarily fixed as 0 volts. Here this is the normal hydrogen electrode in which we will bubble the hydrogen gas onto the platinum foil, which is in contact with the H plus ion solution. So here the standard condition means the concentration of the solution is 1 molar and the temperature is 25 degrees Celsius, and here also the concentration is 1 molar and the atmospheric pressure of the hydrogen gas is here 1 atmospheric pressure. So these are the standard conditions. So at standard conditions, the electrode potential value of a metal is nothing but the potential difference in a cell which is connected to the normal hydrogen electrode. That is called as standard electrode potential, right? So when we connect this zinc electrode to the normal hydrogen electrode, and if we make a cell, if at all the oxidation takes place in our electrode, then we say its oxidation potential is positive, right? So here the zinc electrode will undergo oxidation when we connect to the normal hydrogen electrode. So therefore its oxidation potential is positive, that is 0.76 volts. And we know usually the reduction potential value is reversed to that of oxidation potential for a given electrode. So therefore its reduction potential is minus 0.76 volts. So in this way we will give the sign for the electrode potential. So if at all a electrode is connected to a normal hydrogen electrode, if it undergoes reduction, then the reduction potential value is positive for that electrode, right?